This video is to help find the intercepts of a given equation and to test for symmetry for the given equation. Okay. So the first thing we're going to do is test for the intercepts, and we'll start with the x-intercept. When we are looking for the x-intercept, we replace y with 0. So every place there is a y, we put in a 0. X to the third, x squared minus 1. So the rest of the equation stays the same. Okay, we just now have in a 0 for y. So now our goal would be to solve for x, to find out what x would be. So the first step we see in order to get x by itself is we would want to get rid of the fraction. So in order to get rid of the fraction, we would want to multiply by the denominator. So we would multiply this side by the denominator and multiply this side by the denominator. Now look what happens when we multiply this side by the denominator. This would be 0 because x squared times 0 is 0 and 1 times 0 is 0. So have just 0 on this side. This cancels out. So we'll be left with negative 6x cubed. The next step would be to divide by negative 6 so we can get this x by itself. So divide by negative 6, divide by negative 6. So that's what's going to happen again. I'm going to put 0 again. So 0 equals x cubed. So what allows us to have x cubed equals 0? What would x need to be? Well, x would need to be 0. So in this case, x is 0. So our x-intercept would be 0, 0. Okay. Now let's try our y-intercept. Okay. So the kind of the reverse, I guess you could say it, happens with the y-intercept. Okay. With the y-intercept, you replace x with 0 because we're looking for the y. Okay? So every time we see x, we're going to replace it with 0. So I'm going to have y equals negative 6 times 0 cubed over 0 squared minus 1. Okay? Now we're solving for 0, or solving for y, sorry. So 0 cubed is 0, and then 0 times negative 6 is going to be 0. So this is going to be 0 over 0 squared, which is 0 minus 1, equals y. Now we're going to have y equals 0 over a number. Remember, anytime you have 0 over a number, that just means 0. So y also equals 0. So your y-intercept is also 0, 0. Okay. Therefore, this means that this equation only has one place that it will cross or touch, either the y or the x-intercepts, either one, and the only place it's going to cross or touch is at 0, 0. Okay? So the intercepts for this would be 0, 0. Okay? Next, we test for symmetry. Okay? So we will start with checking for y-axis symmetry. Okay, so we'll start with checking for y-axis symmetry. And I'm just going to go ahead, I'm just going to copy this down as I'm going to move my paper up. So this is going to kind of disappear, but still working with the same problem. So I'm just going to copy it right here. X cubed over x squared minus 1. Okay. So y-axis symmetry, then we are going to replace every x in our equation with a negative x. Okay, so this is y-axis symmetry. So y equals negative 6 negative x cubed over negative x squared minus 1. Okay. So now you want to quote unquote simplify your x's. Okay. So if we have a negative x cubed, we have like a negative x times a negative x times a negative x. Okay. So a negative times a negative is a positive, and then a positive times a negative is a negative. So this would remain a negative x in here. Now you could see this, okay, sometimes people would simplify this even more and say that a negative, quote unquote, it's like there's a 1 right here, okay, so it's negative 1 times this negative 6 right here could be seen as a positive 6. You could simplify this as 6 times x cubed. Okay. Now on the bottom, we'll go ahead and fix that one. Down here, we're going to simplify this negative x squared. So now we're going to have a negative x times a negative x. And a negative times a negative, do you agree, is a positive. So now we have x squared minus 1. Okay. So in order to have symmetry, we have to say that this equation is the exact same thing as this equation. Are they the exact same? The answer is no, because in this equation there's a negative, and in this equation there's not a negative. So the answer is no, it does not have y-axis symmetry. Okay, let's check for x-axis symmetry. And in order to check for x-axis symmetry, we replace a y with negative y. Okay. So where the y is, we're going to substitute negative y equals negative 6x cubed over x squared minus 1. So this is our original, sorry. Okay. So I replace the y with negative y. In this case, is this equation the exact same thing as this equation? The answer is no. So it does not have x-axis symmetry either. So far we have no x-axis, no y-axis. Let's check for the origin. Okay. See if our equation has symmetry with respect to the origin. Okay. So if we're looking for symmetry with respect to the origin, we're going to replace both x with negative x and y with negative y. Y with negative y and x with negative x. Okay. So negative y equals 6 times negative x cubed over x squared minus 1. And I am going to go just a hair faster on this. Do we all agree, right, that when we simplify this equation right here, we're going to end up with this, okay? Because we simplified this, okay? I've done that already. Oops, sorry, I forgot to include that negative. So now we're at negative y equals, my oh my, I didn't do a very good job of substituting that in. Okay, there we go. Now that's going to be a 6x cubed over x squared minus 1. Okay? Now, we do not want to lead with this negative coefficient, so we would divide this side by a negative. Okay? Therefore, divide this side by a negative, or you could see it as multiplying by a negative, right? To get rid of that negative. This would therefore equal y equals a negative 6x cubed over x squared minus 1. Is this, right here, then the very same thing as our original equation? Yes. So, yes, our equation is symmetric with respect to the origin.